You ever wonder what the rules of reality actually are? I'm not talking about the philosophical stuff, but the real hard-coded laws that run everything. From a baseball flying through the air to the stars themselves. Well, what if I told you the cheat sheet has been hiding in plain sight this whole time? Today, we're going to open it up and take a look at the first few chapters. So, at first glance, what are we looking at here? It's just a piece of paper, a physics test. Got some questions about stress, strain, heat capacity. Yeah, it's the kind of thing that might make you break out in a cold sweat just remembering your school days. It seems totally ordinary, right? Just a test. But let's flip the script for a second. What if we look at it in a totally different way? What if these questions aren't just about getting a good grade? What if this piece of paper is actually a page out of a cosmic playbook, laying out the fundamental rules that reality itself has to follow? And that's exactly what we're going to do today. We're going to treat this test like a Rosetta Stone. We're going to decode it to reveal these elegant, powerful principles that shape our entire physical world, from the tiniest particles to the biggest galaxies. So, when you see a question about a car hitting the accelerator or a block sliding down a ramp, what's really being asked? It's not just about crunching the numbers to get an answer. It's about understanding the deep, invisible structure of motion, of energy, and of force. All right, let's dive into Chapter 1 of our playbook, the rules of motion. This is ground zero. It's the absolute foundation you need to grasp to understand how anything, and I mean anything, gets from point A to point B in our universe. And here's the wild part. This whole incredibly complex dance of movement, of everything zipping around, it can all be boiled down to just three core ideas. Three simple laws, figured out by Isaac Newton centuries ago. They seem simple, but their impact is, well, it's everything. So rule number 1 is inertia. Basically, objects are kind of lazy. They just want to keep doing whatever they're already doing. Rule 2 is the famous F equals ma. It's the literal recipe that connects force, mass, and acceleration. And number 3, for every action, there's an equal and opposite reaction. You can't push on the universe without it pushing back. And check this out. These aren't just abstract ideas. They are the exact scenarios we see on our test paper. The car speeding up, the block dragging with friction, the car going around a circular track. Every single one is a little real-world puzzle that you can only solve by using these three fundamental laws. Okay, let's turn the page in our playbook. If motion is the action, then energy, well, energy is the currency that pays for it. Think of it like a universal accounting system that keeps track of what can and can't happen. Now, energy mostly shows up in two main flavors. First, you've got potential energy. That's stored energy. It's the energy of position, like a ball sitting at the very top of a hill just waiting. Then you've got kinetic energy. That's the energy of motion, when that same ball starts rolling down the hill. And this is maybe the single most important rule in this chapter. You can't cheat the system. Energy can't be made out of thin air, and it can't just disappear. The total amount is always the same. As that ball rolls down the hill, its potential energy just converts into kinetic energy. The total amount, it never, ever changes. So how do we actually track this energy being moved around? Well, in physics, there's a special word for it: work. That's the official term for what's happening when a force actually makes something move. It's literally the process of spending that energy currency we were talking about. And this is where it all just clicks into place. One of the questions asks for the work done when a force of 50 newtons moves something 10 meters. You just multiply them, force times distance, and you get 500 joules. That's it. That's the exact amount of energy that was transferred. It's such a simple calculation, but it reveals one of the most fundamental transactions in the entire Cosmic Playbook. Okay, so we've covered the big, flashy rules, motion and energy. But the playbook gets even more interesting when you dig into the more subtle chapters, the ones that govern the forces that are always at play, even when we don't really notice them. Let's look at a few pulled right from the exam. First up, stress. Anytime you pull on something, like, say, a guitar string or a rubber band, there's this internal force inside the material that's fighting back, resisting that pull. That internal resistance, that's stress. And what happens when you have stress? You get strain. Strain is simply the measure of how much that thing actually stretches or deforms. It's the direct physical result of all that internal stress. Okay, so what's the connection? That's where this cool little rule called Hooke's law comes in. All it says is that for a lot of materials, the more stress you put on it, the more strain you get. It's a straight line, a direct relationship. And that simple idea, that's the very soul of elasticity.
And the playbook is just packed with these kinds of hidden rules, each one a fascinating chapter. The test hints at others, like centripetal force, that's what keeps a car from flying off a circular track, or surface tension, the reason a soap bubble can even exist. And simple harmonic motion, that's just the beautiful physics behind the rhythm of a swinging pendulum. All these forces hiding right there in the questions.
So what happens when we step back and put all these chapters together? You start to get a completely new way of looking at the world. It's like you start to see the underlying code that's running just beneath the surface of everything.
This table just lays it all out so perfectly. A question about a car's acceleration, that's really about the laws of motion we see every single day. A question about a slope, it's about the energy conversion you feel on a roller coaster. Those questions about stretching wires and sound waves, they unlock the principles behind everything from a rubber band to the music you're listening to.
And that's really what this all boils down to. A physics test, something that can feel so intimidating and abstract, it's not just some hurdle you have to jump over in school. It's a guide. It's a structured way to learn how to see the invisible rules and the deep, beautiful structure of the world all around us. So, I'll leave you with this. The next time you see a car take a sharp turn, or watch a drop of water cling to a leaf, or see a ball bounce, maybe you'll see it a little differently. Now that you've had a peek inside the playbook, what rule of reality are you going to notice first?